Hello friends, welcome to my next video on index notation. Please, if you're not subscribed to my YouTube channel, do subscribe so that you don't miss the latest videos that I post, so that your understanding in certain topics can be enhanced. Previously we looked at index notation and we did some of the rules and principles of index notation, and today in this video the main focus will be how do we solve the questions that come in ECZ paper 1 question. So that is our main focus, and the questions for today will be as follows according to the principles that we learned yesterday. So if you missed that video, please do subscribe to my YouTube channel so that you can watch the video and understand what we are going to learn today. Thank you for that. All right, so let's begin. There's another thing that we should note before we even progress. Note, when you are given a square root, it is the same as 1/2. Same applies when you are given a cube root like this. There is a square root and there is a 3 there, which simply means it is 1/3. So don't forget, this knowledge is very important. Now here we have standard examination questions. Question number 1, it says evaluate -4 to the power 2 plus 4 to the power 3. This question is coming from October 2014 paper 1. And we also have another one, evaluate 2 to the power 3 times 2 to the power 0, which is coming from August 2015 paper 1. And also we have evaluate 3 to the power 2 plus 2 to the power 3 times 2 to the power 0, which this paper is July 2016 paper 1. Question 4, evaluate 5 to the power 0 plus 5 to the power 1, which is October 2016 paper 1. And we have another interesting one, which is evaluate, open brackets, 81/16 raised to power -1/4 plus, open brackets, 81/16 raised to power 0. This is a 2017 past question from a past paper. Now, how do we answer these questions? Let's start with number 1. So our number 1 is saying that we should evaluate. So this is my number 1. Number 1, it is saying we should evaluate -4 to the power 2 plus 4 to the power 3. So how do we do this? It's very simple. Keep in mind that this negative which is here, it is not raised to any power, but this 4, it is raised to power 2, and this 4, it is also raised to power 3. So therefore this negative, it will just be written as a coefficient of -1 times 4 raised to power 2. It simply means that it is 4 times 4, which is 16. So we are going to write 16 plus 4 raised to power 3, which is simply means we are multiplying 4 3 times. We are multiplying 4 3 times, and that will give us an accurate answer. If we multiply 4 3 times, we are going to get an accurate answer. So make sure that you follow the procedure. You can, if you want, you can do the following. You just say 4 times 4 times 4 3 times, and therefore we have -1 times 16, which is 4 times 4, which is 16, plus 4 times 4 is 16, times 4, that will give us 64. So it will give us 64. Once you have this, therefore now we know what we should do. Multiplication comes first when we do board mass. So we are going to say -1 times -16. We are going to have -16 plus 64. So once we have this part, therefore now you can simplify further. -16 plus 64 is more like we keep the sign of the big number, which is positive, and we subtract the smaller from a big number, which is when we subtract 64 minus 16, we are going to get 48. So our answer will be positive 48, not negative 48, but positive 48. So that's how we do with the first one. Now let us go to the second one. The second one is simply saying we are going to evaluate 2 to the power 3 times 2 to power 0. Now, 2 to the power 3, they are simply saying that we solve this 2 is 2 times 2 times 2 times, again, 2 to power 0. So 2 times 2 times 2, this is same as 2 times 2 is 4, 8 to power 0. So we are going to have 8 times 2 to power 0, it is 1. 8 times this is same as 8. Simple as that. So this is, you do this part, then you are not going to have a problem. Or you can apply the index law, which simply says if the bases are the same, 2 to the power 3 times 2 to the power 0, the bases are the same, add the powers, so but maintain the base. So we're going to say it is 2 to the power 3 plus 0, which is same as 2 to power 3. So 2 to power 3, it is more like 2 times, this is same as 2 times 2 times 2, which is going to be 8 as our final answer. So you can either use the law of indices like this, or you can just go direct and you get the same answer. That will not be a problem. Okay, hope that was helpful. Now let us go to question 3. Question 3, it's saying that we should evaluate 3 to the power 2 plus 2 to power 3 times 2 to power 0. Okay, so we can use the BODMAS rule, which simply says that if the bases are the same, we can add the powers and maintain the base. Or we can use the different method, but let us use what we learned yesterday. So we are going to say 3 to the power 2 plus, these bases are the same, so we maintain and we add 3 plus 0, which will just be 3. Correct. So now, what are we going to do when we have 3 there? We are simply saying that 3 raised to power 2 plus 2 raised to power 3. So 3 raised to power 2, that should be 9 plus 2 raised to power 3, that is 8. So when you add this now, we are going to get your answer to be, okay, so we are saying that what is the 9 plus 8, which is 17 as our final answer. So you do this, then you will not have any problem. Okay, now let us go to the next question, which is question 4. Question 4, it is simply saying that we should, question 4, we are saying that 5 to power 0 plus 5 to power 1. How do we evaluate this? This is 5 to power 0 plus 5 to power 1. What it simply means that any number raised to power 0, it is equal to 1, plus any number raised to 1 or unit power, it is simply that actually base. So 1 plus 5, this will be 6 as our final answer. Good. Now let us come to the difficult, to something which looks complicated but simple. Number 5, and this will be our last one. 81 over 16, or this is enclosed in the brackets, negative 1 over 4 plus 81 over 16, or this is raised to power 0, or this is raised to power 0. Okay, so how do we solve this question? So how we solve this question is very simple. All you need to do is, how do I get rid of the negative sign? So the negative sign, you can easily get rid of it using the laws of indices, or you can use this straightforward. You see, this is negative 1 over 4. Once you make the denominator be the numerator, then it means that you have worked out this and change this part, which is, not this part, but this side. Make this denominator 16 be the numerator and this numerator be the denominator, and it means that the negative will disappear. That is the simplest way you can solve this kind of equation. Okay, so now let us solve this kind of equation by simply doing what is supposed to be done. So we are saying 16 over 81, or this, it's supposed to be enclosed in the brackets when we say 1 over 4. The negative has gone because we have swapped this, plus 81 16 to power 0. Now, once we have this, then we have no problem. All we need to do is to apply the laws of indices, which simply says that this part, it is 16, okay, 16, which number 4, okay, to the power, multiply this by 1 over, again we do the same, 81 to power 4, multiply by 1 plus any number raised to power 0, it is 1. So now we say, which number can we multiply 4 times and we are going to get 16? Which number can we multiply 4 times and we are going to get 16? That is what they mean when you have this kind of a question like this. So what is that number? We are saying, okay, so now, which number can we multiply 4 times and I'm going to get 16? That is 2. When you multiply 2 times 2 4 times, you're going to get 16. And which number can we multiply 4 times and we get 81? That is 3. And this is plus 1. It means that we have dealt with this part. Now we can come and simplify this part. Over 1, we find the common denominator, which is 3. 3 into 3, that is 1. 1 times 2, it is 2. Plus 1 into 3, that is 3. 3 times 1, that is 3. So we have 2 plus 3, which is going to give us 5 over 3. You can leave your answer like this, but always change the improper fraction to be a mixed fraction. So our final answer, therefore, will be 3 into 5, which will be 1, remainder 2 over 3. So that is our final answer, and that is how you work out this kind of a question. So these kind of questions are very important. Please don't take for granted because they look so simple, because they will challenge you in your final examination, grade 12. Okay, thank you for watching the video. Please, if you're not subscribed, do subscribe, and if you need further help, please do call the number that is popping on your screen, and I will be able to assist you and to help you understand further and further. Don't miss out the next video, because the next video will look at the equation of indices. How do we solve the equations of indices? That you should not miss. Thank you.